Good morning, students. Today we are going to see about production of X-rays, which comes in our second unit of atomic and solid state physics. Yeah, X-rays were discovered by Roentgen in the year 1895. X-rays are nothing but electromagnetic waves of shorter wavelength around 10 Armstrong to 0.5 Armstrong. Since its variation from 10 Armstrong to 0.5 Armstrong, we can produce a soft X-rays and hard X-rays. That is, when it is a longer wavelength, it is called soft X-rays. When it is a shorter wavelength, it is called hard X-rays. Now, we are going to see about the production of X-rays. In the production of X-rays, the main important apparatus is a Coolidge tube. Yes, Coolidge tube. When the X-rays are produced, when the fast moving electrons are suddenly stopped by a solid target. How X-rays are produced? X-rays are produced when a fast moving electrons are suddenly stopped by a solid target. Yes. For this, we need a Coolidge tube as shown in the figure. See here, in the figure, we are having that Coolidge tube. First, the step is the air inside the Coolidge tube should be evacuated. How? By using a rotary oil pump up to 10 power minus 3 mm of mercury, we can create a vacuum, and after then we can use the mercury vacuum pump to create about 10 power minus 5 mm of mercury. Yes, this is the first step, because what we say that the X-rays are produced when a fast moving electrons hitted on the target. Yes, suddenly it hitted on the target. If there is a presence of pressure, what happens then? There will be deviation in their path. It will not be moved towards the target, it moves somewhere else in the pressure or air. So we need to create a vacuum inside a Coolidge tube. Yes, this is the first step. The tube is exhausted to be a possible vacuum in the order of 10 power minus 5 mm of mercury. Yes. The cathode consists of a tungsten filament F heated by a low tension battery. The cathode consists of a tungsten filament which is heated by a low tension battery. Yes. By thermionic emission, the thermionic electrons emitted by the filament are accelerated towards the target T, which is at the high potential maintained between this target and the filament. Between the target and the filament. Yes, the filament is placed inside a cup-like structure which is called a G, which is connected with an anode. Yes, we can say this. The filament the target T is fitted in the metal cup G to focus the electrons on the target. The target must be cooled to remove the heat generated in it. By continuous bombardment of electrons from the cathode, we have to cool down the target material. Okay. The usual method is to mount the target material on the hollow copper tube through which cold water is continuously circulated. The target is made up of metal like molybdenum or tungsten. Okay, that is they should be high melting point and with high atomic number. Metals with a high atomic number give more energetic and intense X-rays used as a target when compared to the tungsten material. Okay. Then in the Coolidge tube, the intensity and the frequency of X-rays can be easily controlled. Yes. Initially we said that there are two types of X-rays. What are they? That is hard X-rays and soft X-rays. How it is named is, when it is a longer wavelength, it is called soft X-rays. When it is shorter wavelength, it is called as a hard X-rays. Then how we can name it like this? By varying its wavelength, we are saying that. How it can be controlled in the production, that is the main point. The 2 points are there. That is the intensity and the frequency. How this intensity can be controlled? The intensity of X-rays depends on the number of electrons striking on the target material coming out from the filament. That is the matter. Okay, the intensity of X-rays depends on the number of electrons striking on the target per second. Okay, the number of electrons given out by the filament is proportional to its temperature. When the temperature increases, there will be more number of electrons coming out. When the temperature decreases, there will be less number of electrons will be coming out from the filament. So this filament is heated up according to the particular temperature. The electrons will be thermionic emissions will be happen place, and the target will be reached, and the intensity can be controlled by the filament intensity, filament temperature. Okay, so the intensity of X-rays varies with the filament current. Then the second one is the frequency. How the frequency of X-rays can be controlled? Yes, it mainly depends on the voltage between the cathode and the anode target material. Yes, the frequency can be controlled by varying the cathode voltage between the cathode and the anode. We have this, no, the high voltage source here. Okay, it can be controlled by potentiometer arrangement. Also, we can control this, the potential between the anode and the cathode. So what about this? If E is the charge of the electron, what is the work done on the electron moving the cathode towards the anode is equal to a 1 number electron volt. 1 number electron volt. The electron thus acquires the kinetic energy which is converted into X-rays. When the electron strikes the target, then the X-rays are produced. With this formula, E is equal to h nu. E is equal to h nu. Thank you, students. So today we have seen about the what is by X-rays and how it can be produced. And after then, the next class we can see about the Bragg's X-ray spectrometer. With this, we were using a Bragg's law, and then we can see about the characteristics of X-ray spectrum. Thank you, students.